Good morning. Today we're going to be taking notes on finding the area of special figures. This is in addition to what we took notes on the last time, using the formulas of areas to find the area of triangles and rectangles. Using that knowledge, we're going to use that to find the area now of some special shapes. And we're going to do that by doing a process called decomposing. If you think of the word decomposing, think of the prefix D, which means to do the opposite of something. And composing is to think of if you compose a piece of music, you're building a piece of music or you're creating a piece of music. So the opposite of composing or creating is to take apart something. So we're going to deconstruct a shape, and that's what's going to help us find the area of that shape. There are formulas that eventually we'll learn to use to find the area of parallelograms, triangles, rhombuses. But for the sake of today, we're going to use these as shapes that we don't know those formulas, or we can't use those formulas, and we have to decompose them in order to find them. We are using the standard 6G1, which is our first geometry standard. And it is, by the time that we're done with this lesson, you should be able to find the area of special figures by decomposing them. And we're going to be focusing really heavily on quadrilaterals. A quadrilateral is a shape that has 4 sides and 4 angles. There's different quadrilaterals. There's squares, which have 4 of the same sides and 4 same angles. There's rectangles, which have 2 sides that are the same, that are congruent. Actually, it has 4 sides, but 2 sides match and 2 sides match. We also have rhombuses, which are kind of like diamonds. Trapezoids are quadrilateral. They remind me of, if you've ever seen a circus, the elephants stand on those little blocks, and they're smaller on the top and bigger on the bottom. That's a trapezoid. We also have parallelograms, which is like if you take a triangle or a rectangle and you kind of smush it a little and it gets a little wonky and off to the side. That's a parallel or a parallelogram. Yeah. Okay, so the first thing we need to write down is we need to write down our formulas that we do know, and we're going to write down the formulas for rectangles and triangles. So first, for a rectangle, can anyone with a quiet raised hand tell me what is the formula we use for a rectangle? Raise your hand. Angel? No. You multiplied 1 too many, my friend, but you're close. Noah? The length times the height. We usually say either the base times the height or the length times the width, but you had it. So length times width, or length times width. Okay, and then we also need to know triangles. Can anybody tell me what is the formula for finding the area of a triangle? Ryder? Thanks for standing.
Base times height divided by 2.
Base times height divided by 2, right. Because remember, we know that a triangle is half of a rectangle, right? And a rectangle is base times height, so it would make sense that it would be half of that. You can also write it as 1/2 times the base times height. Okay. So, with that understanding of those are our formulas, we're going to break down these shapes. So let's look at this first shape here, and this is a trapezoid. Remember what I talked about, that elephant standing on the block? That's what it reminds me of. I think of a circus. So this particular shape is actually 3 shapes that we can make it into. Can somebody see a place where we can divide it to make it into 3 different shapes? Justine?
We can make it into 2 triangles.
Uh-huh.
And a...
What would the shape in the middle be?
A trapezoid? Wait, no, hold on.
Somebody help her out. What do you think? Noah Engel?
You would make it 2 triangles and a rectangle.
Good. Okay, so class, help me out here. I'm going to start my pen over here, and I'm going to start sliding it. You tell me when I should stop and make my line to make the first triangle.
Stop.
There?
What do you know?
All right. This side. Look at this side, okay? Whoops.
Oh.
Right there, right? So, would it be easier if I used a ruler? How about I do this? Okay, you tell me when this line is where it needs to be to stop. I'm waiting. Do you like how obvious that was? So if I stop here, look, okay, does that make a triangle here? Yes. Okay, let's try it again. I'm going to keep going. You tell me when I get a triangle on this side.
Stop.
There we go. And so now I have a triangle right here too, right? Okay. So now I have a rectangle and two triangles. And while I did not do a great job of drawing it, they should be congruent. This one should be the same as this one. But I didn't do a fantastic job of drawing it. That was totally my bad. Okay, so let's imagine that the top here is 6 inches. The bottom from here to here is 8 inches. And our height from here to here is, let's do 4 inches. Which is hard to see, so I'm going to also, from here to here is 4 inches. Okay, we have one rectangle first. So our one rectangle, we know that our formula is length times width. What is the length of our formula? And keep in mind, we're only looking at this space. We're not looking at the lengths of the triangles. So can somebody figure out what would the length be of just the rectangle? Raise your hand. Look, if I take out the triangles on each side, what would the length be, Serena? 6 inches. Good. Okay, so I have 6 inches times. Now what would the height be? What would the height be of that rectangle, Riley? 4, right? It'd be with this. Okay, class, what is 6 times 4?
24.
So 24 inches, and because we're doing area, we have to square it, right? Okay, so now we have two triangles. Those triangles are going to use the formula base times height divided by 2. Okay, so let's look at just this triangle. We don't know what the base is, but we do know that the base up here at the top of our trapezoid is 6. If I go down, this bottom space would also be 6, but I know the distance the whole way across is 8. So what is the difference between the top and the bottom? What is the difference, Lane?
They're separated by 2 inches.
2 inches. Okay, so if that's the case, I want to divide it because I have two congruent triangles on each side. So what would the base be of each of my two congruent triangles, class? 2. What is it divided into each individual ones? 1, right? So this would be 1, and this would be 1. So our formula would be then base, which is 1, times, what is our height? Class, what's the height? 4, divided by what? 2. Good. So 1 times 4 is what, class?
4.
Divided by 2?
2.
So one triangle would be what? 2. But we have how many triangles? 2. So what is it all together? 4 inches square. Okay, so now we know this is 24, this is 4 together. So we would add it together. We would say 24, our rectangle, plus our two triangles, which is 4, equals all together for our shape 28 inches squared. Let's look at our little house. Okay, do you see the house?
Yes.
Can somebody tell me how I can divide this into two shapes that we can solve? Daphne?
Triangle and a square.
Triangle and a square. So wouldn't I draw my line right? It's actually not a square. It is what instead, Daphne? A rectangle, right? Because if it was a square, they'd have the same sides. So let's give this section here, let's say it's 9 centimeters. Let's say from the top of our house to the bottom of our house, it is 13 centimeters. And let's say that the base is 10 centimeters. Let's first, Logan, figure out what is the formula for the rectangle that we're going to find. How do I find the area of a rectangle? Hayden?
Length times width.
Length times width. So we're going to do our one rectangle. length times width, which is going to be 10 times, what is the width going to be on that one? Raise your hand if you can tell me what is the width. And don't get stuck because you might get tricked. Lane.
Isn't the width 10 centimeters?
It's 10 times, what am I multiplying it by?
9.
Why 9 and not 13?
Because weren't we going to do the rectangle?
Just the rectangle. You're right. Because the rest of the 13 is part of the triangle at the top, right? Good. So we would do 9 times 10. Which, what is that, class?
90.
So our rectangle here is 90 centimeters squared. Then we have one little triangle. Remember triangle? What is the formula for triangle? William?
Base times height divided by 2.
Base times height divided by 2. What is your base going to be? Raise your hand if you can tell me. Riley?
10 centimeters.
10. Can somebody tell me what the height is? The height. Serena? Why do you think 9 centimeters? So we use the 9 centimeters for this rectangle, but aren't we looking more for this distance here? So what would that distance be? Yoslin?
4.
4. Why 4?
Because 9 plus 4 equals 13.
So you took this that we know, subtracted it from the 13 that is the full length, and you got that this length would be 4. That is correct. Okay? So we would do base, which is 10, times the height, which is 4, divided by 2. All right, class, 10 times 4?
40.
Divided by 2? 20 centimeters squared. Now, am I all done?
No.
What do I have to do? Add it up. So we're going to do 90 plus 20 equals what, class? 110 centimeters squared. Awesome, guys. You guys are doing fantastic. Let's go to 127. All right, we have no triangles on this one, but we have 2 other shapes. What shapes do we have? What shapes do you think we have? Ryder.
We have a square and a rectangle.
You want to do a square and a rectangle? We can do that. So we're going to divide it here, I'm guessing, Ryder. Is that right? Okay, so we're going to say up here is 5 inches. Over here, 11 inches. Across the bottom, 18 inches. This, 13 inches. And over here, 5 inches. So we have 1 square. How do I find what is the formula to find the area of square? I didn't write this one down, so I don't know if you remember it. What do you think, Kaylani? No? Yes, Noah?
I don't think it's the same formula as a rectangle.
It is the same formula as a rectangle. It would be length times width, but here's where you could write it another way. Because aren't all your lengths the same? All your sides are going to be the same? So couldn't you just say side squared? So side times side, because they're all the same. It isn't a square, because I did a wrong thing here. Let's fix this. Make this a 10. Thank you for catching that. I made a mistake. It happens. So if this is 5 and this is 5, then this would equal 10, right? Yeah. So you would do 5 times 5, which would be what? 25 inches squared. And then you have this rectangle down here, which would be length times width. What is the length? 18 times what is the height or the length? That's the length. What's the width? 5. All right, so let's do 18 times 5. Sorry, I flubbed that up. 8 times 5 is 4. And then, yeah, you get 90. So we'd have 90 inches squared. We have to add that together. 90 plus 25 equals 115 centimeter or inches. Man, I'm messing up. Squared. Good thing I have you guys around. All right. I want you guys to try on the next 2. This one here, is 18. And we're going to say 21. And we're going to say the length, the height here of our triangle, because we're going to have two triangles on each side. That is going to be 5. So this is 5. So keep in mind you're going to have two triangles and you're going to have a rectangle.
Wait, what if we don't want to do it like that?
You can do it another way if you want. Okay, and then the bottom, this shape is called a rhombus. It's like a smushed out diamond. And on this one, we're going to say that it is 6 this way. And this way, across from here to here, we're going to say is 10. So how many triangles do you have on that one? 2. And what is your formula for triangles? Base times height divided by 2. So what I'm going to have you guys do now is I want you to do the last 2 in your groups. Okay? Work together, make sure everybody has it, and you can then do questions and summaries when you're done. Thank you guys so much.